Третє. Okay, am I live? We are live. Nice. Sorry about that, guys. Technical issues today. Let's continue. Do you hear me? Let's go. Nice. Let me just try and just give me a second. Let me open up the. How is my sound like? Is it better now? Let me just go to my channel. Videos. Where is my live stream right now? Part 2 live. Okay, I see it. I don't see how many people there are. A second. We're gonna start in any better voice, right? Is it better than what we had before? Or is it the same quality? Sounds great. Okay. Nice, guys. Okay, I see 7 people watching. Let's maybe, yeah, I think we can just start. There will be a recording for those of you who want to jump on later. Let me just see one thing. Whether I can open up the. Okay, all good. Let's get back to it. We stopped at the evaluation for mining. So on pure translation performance, we observed that the fixed site representation bottleneck leads to 7% and 13% decrease in blue score when translated into English and out of English, respectively. Okay, this is a rather interesting result, given that the use of attention is commonly considered mandatory to achieve reasonable performance. Let me put the chat here. Okay. On mining performance, we rely on the multilingual similarity search, XSIM metric. That was a metric that they introduced in some of their previous work, which measures the percentage of sentences in the floors dataset which are not correctly aligned when searching for the closest vector in the embedding space. The improved version, XSIM++, added challenging English sentences on the target side. Both of these metrics are a good proxy to the actual T2T mining task while being much faster to compute. Okay, summarizing table 9, Sonar substantially outperforms other popular multilingual sentence representations like Laser 3. Okay. So lower is better here on all 200 floors languages. Huh. So now I'm confused. Like, why is this? Why do we have such a big improvement here compared to the table we saw up above here? So here they were on floors dev set, and here it's also floors. Huh. So maybe the blue metric doesn't capture some of the nuances or whatnot. Okay, we'll figure it out later. It doesn't matter that much now. Architecture and training setup. As a second step in following this work, the new Sonar text embedding space is extended to the speech modality through teacher-student training. In that work, a fixed size speech representation was obtained by taking the BOS, the beginning of sentence output, of a pre-trained XLSR model. This model was then fine-tuned to maximize the cosine loss between this called speech representation and sentence embedding in the same language or in English speech translation. Okay, basically, let me try and quickly pull out a relevant work here. Just a second. Let me do it like this. Let's search for Niels Reimers. He is Google Scholar. As I said, we'll have this guy early September coming to our server, talking a bit more about his work. I think this was the work that we care about. Let me just quickly jump there, open up the archive, and see whether there is a nice diagram. Yeah, here is everything you need to know. So how these multilingual embedding spaces are trained is basically you have teacher and student, and basically you pass in the, for example, English sentence into the teacher. Out comes a certain representation, so you maybe do some mean pooling at the output of the transformer decoder in case that's how this is implemented. And then Hallo Welt, this is like a German sentence, which also means hello world, as you can probably infer here. And then you get representations. So this is a multilingual model. So it outputs two representations, and you want to make sure that both of these representations are the same as the one here, which means you're forcing them to be the same, and thus you're forcing German and English embedding spaces to be aligned by the MSC loss. So that's kind of the high level understanding there. Nothing super fancy there. Okay, let's get back here. Architecture and training setup. As a second step in following the work, I think we read this. Okay, they improved the recipe by doing the following. The MSC loss instead of a cosine loss was used. This enables us to use the sonar text decoder on speech input. Okay. And then this model here, instead of the XLSR is used. This was optimized for 143 languages. We'll see what that is a bit later, probably. Attention pooling, instead of the usual pooling methods like mean or max pooling, we implemented a 3-layer sequence to sequence model to convert the variable length sequence of this BERT model to a fixed size vector. Okay, so they have kind of learned how to condense the information as opposed to just using some heuristics like mean pooling or whatnot. Training on human performed ASR transcriptions only. We collected at least 100 hours of ASR transcriptions for most of the languages and trained the speech encoders exclusively on them. Okay. And following this work, we grouped languages by linguistic families and trained them together in one speech encoder. This makes sense. Otherwise, you have to go the mixed expert, the MOE, my brain is not working, MOE, mixture of experts model. Alternative language groupings which might consider the acoustic characteristic of each language or left for future work. Okay, we saw this table before. Evaluation of speech encoders. The paper is super, it's not really, I don't like the way they wrote it compared to NLLB. It's spread out a lot and not really clear, really. They're saying a lot of words, but like it's not the best paper I've seen. Okay. Okay, this is compute intensive. Let's see why. Instead, given that the Sonar embedding space comes with a text decoder, we chose to evaluate the individual speech encoders on a speech-to-text task. We decoded foreign speech embeddings into English text. Results are summarized in table 10, column. It's important to emphasize that the Sonar speech encoders were trained on ASR transcriptions only, and the Sonar text decoder has never been exposed to any speech input. Therefore, the reported results correspond to fully zero-shot speech translation. Okay. Despite the zero-shot. Okay, they compare Farewell with the Whisper Large V2, which is the largest checkpoint from Whisper. Gaps can be observed in some high resource languages like German, Russian, Portuguese. Zero-shot performance, particularly for Swahili and several South Asian languages like Bengali, Kannada, Telugu, and Tamil. There are so many languages I never heard of. Do you guys still hear me? The interface for live is not the best. I'm not really sure. Just a second. Sorry, guys. Okay, thanks, Brian. If that was in reply to my latest question. I'm losing my voice. Oh my God. Let's go. Margin setting. Okay, this is the usual thing. Margin criterion when you're trying to find the close points in the embedding space. They perform the so-called the global mining, which is more compute intensive because you're trying to compare. Basically, you're doing an exhaustive search of a single point across all of the different points in the embedding space, and there can be many audio files where all speech segments in one language are compared to all speech segments in another language. Yeah, or local mining country. Let me know if you can hear me eating the cookie. If it's annoying, I can't do it. Okay, local mining is when you literally have segments from a single audio file or whatnot, and then you do local search. Although, I wonder how many times you find a single audio file that has multiple languages. Yeah, that's hard to. Such high level information is very difficult to obtain scale. They use the Vice library, which is Facebook's vector search database, basically, to do this type of mining, enabling efficient large-scale similarity search on GPUs. This is important. We need more GPUs. Finally, nearest neighbors to all elements in both directions are retrieved. All good with the cookie. Nice. So here's how the margin is computed. Yeah, so usually how you think about this similarity search, you think you're just doing like a cosine similarity between the embeddings, but in reality they use a more complex function because this one, I think because of the scale, you cannot just do cosine for some reason. Let me just think. If you do dot product, then you have scale issues, right? Because if you have different size vectors, the longer the vectors, the bigger the dot product, and then they're not all on the same scale. But if you have cosine, that should be good, right? Because cosine normalizes by the norms. But they have to either case have this additional formula where they find other neighbors in the target space, and then they do this type of summation, and then margin is basically, I think they do ratio. So margin is just some function, and they do cosine over this number here or something like that. Anyhow, it doesn't matter that much. Let's just continue. And they set k to 16. That means, oops, fuck my life. Why is this? Why did they have to change my Adobe Reader the day I'm streaming? Really? Okay. Okay, they used threshold of 1.06 in the previous work. I remember that. And then the zoner space, however, displayed different dynamics, and the optimal threshold was adapted accordingly. Since full end-to-end evaluation is too compute intensive, we set the new threshold at 1.15 after some human inspection. It's going to be fun mining this data. Even for text, it's super compute intensive. Okay, let's see whether we missed something up there. Did we have something? No, I think we're good. Let's just keep on reading and find interesting parts. Mine dataset, we perform mining of speech in foreign languages against English text and English speech. Okay. Given the sheer size of the corpus, 1 million hours, and 4 index collections, we carried out this mission only for some languages. Okay. Other directions are left for future work. Fair enough, except for Maltese. Okay, they can find at least 100 hours for English and other foreign languages other than Maltese. The alignments with English text reached 1,000 hours for most languages and exceeded 10,000 hours for 6. These are the classical high resource languages. Overall, the Seamless Align covers 37 languages and a total of 470,000 hours. Okay, we can find the metadata in their repo. That's a good thing. Adding such huge amounts of data to train a massively multilingual translation system represents a substantial computational challenge. As described in the section, not all of this data was used for modeling, but only a subset with high zoner alignment scores. I love when they reference future sections, as mentioned in section that you did not read. Since our mine data can help support many different use cases, we are open sourcing. They are open sourcing. Okay, I hope they're really open sourcing the metadata. You cannot not open source it if you shared it, I guess, for the full amount. Okay. To allow the community to rebuild and use it for their own purposes. I guess they have to do this to just, if it doesn't make sense where they're doing this, probably just legal claims. They don't want to end up in the same situation as OpenAI and Stability, some of these companies. AI tech companies are increasingly becoming legal companies. the sad reality we live in. Okay, I think that's it, guys. This part we can related work. I think we can just skip. Let me just skim this quickly. Nah. Related section is usually something I always skip. Not a big value add. Speech segmentation. Yeah, okay, so it's commonly used pause-based segmentation using voice activity detection. We saw this before. They adopted the over-segmentation strategy. We saw that while this over-segmentation significantly improves the recall of the mining process, it does come with certain drawbacks. Substantial increase in the number of segments, 8x. Okay. Okay, the VAD has its own issues because of the pauses. Okay, nothing interesting there. Laser, Lab C, we saw this. These are just some basically embedding models for mining parallel text data. That's how Laser, that's the context that Laser was created in. Okay. And then Laser 3 was used in NLLB, and they just extended it to 200 languages. Again, those are just those models that embed sentences from different languages into the same space, and then you just mine them. Speech mining. Okay, they just created a speech matrix in previous work with this speech mining technique. That's probably also from Facebook, I assume. Yielding a total of 418,000 hours of speech-to-speech alignment. Okay. Totaling 418,000 hours of speech-to-speech alignments, out of which about 46,000 hours are aligned with English. Wow, that's a small amount. But the domain is limited because the raw audio is derived only from European Parliament speeches, which means there is no variability in how people, different accents, different dialects or whatnot, pronunciations. That's why it's kind of limited. Okay, let's go to the SeamlessM4T models. Although I think the main thing is going to be always about data here, right? It's going to be about mining these large parallel speech, text to speech, speech to text, all combinations thereof. Okay. Direct speech to text translation models have made progress. Oh my God, so much text and saying nothing. Arrival of massively. Okay, stating the same thing they stated multiple times already. One of our goals is to bridge a gap. Okay, I know that. Beyond text outputs, our second goal. We enable speech-to-speech translations with Unitary 2-pass modeling framework. Can be jointly optimized. There are two views of what constitutes a direct model. A model that directly predicts. Okay. The aforementioned approach alleviates the issue of cascaded error propagation. That's what we said before, right? If your first element in the cascade is introduces error, then the second one is just going to amplify it at best. Okay, let's see the figure 4. Here's the overall system. One shows the pre-trained models used when fine-tuning multitasking in Unity. 2 outlines multitasking Unity with its 2 encoders, text decoder. T2U, what does U stand for? Let me see. Okay. Text to unit encoder decoder. And then there is a vocoder. And there is a conformer, and there's just a ton of components here. A length adapter, I have no idea what it does. Do you guys still hear me, or am I speaking too quietly? Let me know in the comments. Because I changed I'm now using the earbuds. Before that I was using the Sony ZV, whose battery died off. So I had to change and start a new stream. Okay, text to unit. I guess unit is just some representation before you convert it into actual audio file. Okay. Nice, thanks guys. Okay. After 1 minute. Why is the lag so big? I'm literally like this YouTube notion of live is like not really live. Like I'm 1 minute ahead of you. I can't get direct replies as we go. That's weird. Maybe is it because of my like camera? Maybe I need to reduce the bandwidth. Okay. So 4 building blocks. Let's just start here again. So the aforementioned approach is the issue of cascade error propagation and domain mismatch. The vocoders for synthesizing speech are trained separately. Figure 4 provides an overview of the SeamlessM4T 4 blocks. Massively multilingual. Okay, so this is the one important component is the NLLB. Google says you can choose your latency. That's interesting. Let me see whether I can do that. Just a second. I think you can pick the delay in case you need to kill the stream ASAP. Okay, just a second. The next streams are gonna be so much better. This first one, I'm just figuring stuff out. Content, live. Here is this one. I'm trying to edit something here, customization. Can I do something here? Live reactions, slow mode. No. Guys, I don't see any way to change this. Live chat. I've enabled everything possible here. So it might be that I have to change a setting in my OBS to have you guys be actually live. Let me just remove this. If I go to settings, stream, I don't see where do I set the encoder preset slow but good quality. Maybe I have to. Let's try. Huh. Okay. I guess I'll just do research after the stream, and next one will be better. For now, let's kind of do it like this because I don't want to mess something up. You need to choose ultra low latency. I'm not sure how to change that without crashing the stream. I can maybe try, like if I do this, and if I go let's try this. Medium quality. Apply. Okay. Let's see whether the difference is a bit lower now. Okay, I changed it under to the medium setting. Anyhow, let's continue. So 4 blocks. The second one is this BERT model, a speech representation learning model that leverages unlabeled speech audio data. T2U, a text unit, and multilingual hi-fi GAN unit vocoder for synthesizing speech from minutes. Okay. Okay. Okay, so there are 3 building blocks. Oh my god, there's just what is this, guys? The worst paper ever. SeamlessM4T multitasking unity model integrates components from the first 3 building blocks and is fine-tuned in 3 stages, starting from an X to T model with English target only and ending with a fully fledged multitask system capable of performing as well as ASR. Okay. Unsupervised speech pre-training. We then introduced the X to T model, starting with a data preparation pipeline, and then the multilingual. Okay. Next, we'll look at the S2ST task, starting from the acoustic unit extraction pipeline and vocoder design to map units back to speech. Then we describe T2U pre-training, ultimately outlines how all these components come together in the third and final stage. We evaluated our model using standard automatic metrics in section 4.4 and compared its performance with state-of-the-art speech translation. We're going to skip, let me just see how long this paper is, because with this tempo, we're not going to get really far. I'm going to skip a lot of the parts about, oh my God. Luckily, there is a bunch of references and tables here. Let's see effectively how many more pages we have. Model details. Let's maybe go a bit randomly now and see ethical considerations. Let's see what else is here. Training data, metrics. License. Oh yes, our favorite license, guys. CCBYNC40. Okay, just bunch of tables. Not like any normal human can parse these. Data statistics. Okay. Fair 2. Let's kind of read this part. And usually when I read papers, like obviously this is I'm streaming, so I'm trying to do it a bit differently. But like I would skim like this. I would just find the open source, says Rafael. Uh, I would just find interesting snippets. Maybe I can do it like that next time. But like we won't be reading paper. We will be mostly coding, starting from the next stream. So this is an open source library of sequence modeling compliance that provides researchers and okay. It's MIT license, thanks God, and available at GitHub. State-of-the-art implementations of transformers and their components. Fair2 data, scalable pipeline API that enables text and audio preprocessing, transformation, shuffling, and batching in a streaming manner, similar to like I guess Mosaic ML has this streaming data sets. Very cool repo. Allowing training over multi-terabyte datasets without explicit data preparation steps or data loading timeouts. Core building components, blah, blah, blah. Build with extensibility in mind. Another guiding principle, clear separation of core and experimental code. That means, like compared to Hugging Face, like these guys are actually creating abstractions, centralized abstractions, and Hugging Face is much more about copy pasting, and they do that for a good reason. There is a blog by one of the guys from Hugging Face where they write up why they didn't follow the so-called dry approach, which means basically you don't want to have redundancy in your code base. Too much redundancy. You want to abstract away commonly used pieces of code. I mean, just like sane software engineering practices, but like Hugging Face kind of went the other route, and Fair2 is much more aligned to the usual way people build libraries. Okay, so they basically are trying to solve some of the technical debt that the Fair2 1.0 introduced. There is a bunch of libraries, they say, and because of that, they shifted to meet the diverse expectations of these environments, shifted from the idea of self-contained single stop for all training, evaluation, and inference. There was a set of independent components that can be used and extended outside of Fair2. Compatibility with PyTorch. Okay, again, how can you say so much and yet you say so little? Let's go back here. So many references. Acknowledgements. Here's the team behind the project. Basically, LSing the directory that contains all of the employees of Meta AI. Let's kind of go the opposite way a bit. We started from the beginning, now we're gonna go in the opposite direction. um, If paper is 100 pages long, it's either mostly BS or needs to be 5 pages paper. Yeah, I mean, NLLB actually had a ton of interesting information. I actually read the paper, the whole thing, and I enjoyed it. Um, the outro is basically intro with just rewordings, augmenting social impact and conclusion. So we are now at 70 and we were at 30. So we have 40 pages in between that we're gonna skim after this and see what's the most important, because, well, I think I'm gonna be doing this until 5 p.m. So maybe we can try and cover most of it, but I don't feel I'm getting a decent mental model by doing this. It's just too many components, moving parts, and too little, too verbose for the amount of information conveyed. Who writes this, guys? Who has the time to write this? Okay, here's maybe we can understand this part better from this piece of text by fusing 4 building blocks. Again, they have this SeamlessM4T NLLB, a massively multilingual T2TT model. I hate pronouncing these acronyms. BERT, a speech representation learning model pre-trained on non-labeled speech. T2U, a text-to-unit multilingual coder for synthesizing speech from units. We built a unified model. ChatGPT, yeah. Notably, compared to previous work, uh, okay, what's the world readiness? The world we live in has never been more interconnected. A measure of how competent a person is to take on the polyglot world. Say this to English speaking folks. They usually only speak English. I guess it's enough. We believe that language acquisition should remain. Just curious to see what they're saying here, to be honest. In other words, speech is often deemed more challenging than reading or writing. That's because the schooling system got it all flipped. Basically, you focus too much on reading and writing instead of focusing on speaking and listening. I wonder whether Facebook is ever going to deploy some gadget that's going to enable us to do this type of translation, like a actual how do you pronounce it? Babelfish? Babelfish? Okay. Again, nothing special there. Let's go back. We're definitely not going to go through all of this, especially not the biases and all of this toxicity. So I think we don't have more than 20, 30 more pages, even less. We're going to skim toxicity, responsible AI section. We're going to skip. We're not responsible. We're we're going to skip this whole part. We don't really care about it from the capability standpoint. Somebody's gonna extract this piece of the live stream, and then this is gonna haunt me for the rest of my life. Let's go back here. Okay, back to our code blocks here. Let's now dig a bit deeper into this architecture to see, like, I don't know, like some of the models I read recently for text to speech, like Bark from Suno AI and Tortoise, they don't have these units anymore. They're just like literally training big ass transformers. And I think this work probably started way before of those some of those papers were published. So maybe they already mentioned that somewhere that they didn't have MMT available, the other work from Meta available. So maybe I have no idea how long this work was in the making. Okay, let's kind of go from here and continue. Okay, let's see this. Unsupervised speech pre-training. So I guess that's the second component, the BERT model. By the way, I don't know. Do you hear any background noises when I'm not speaking? Let me know in the comments. Okay, so contrastive learning and mass prediction learning, and improves per additional codebooks. Thanks, Rafael. Visualization. The later refines the contextualized representations by a different learning task. Codes directly instead of polarizing the prediction probability of correct and incorrect codes. This is just the usual, all of those papers, like from especially the ones for image generation that I've covered before my channel, like VQ GANs, etc. All of them use these types of codebooks. The overall training is defined as follows. There is a ton of components and a ton of loss components for each of the subcomponents. It's just okay. We follow the. Ultimately, this is all super simple. It's just you have to start coding stuff. 24 conformer layers and approximately 600 million parameters. Train on 1 million hours of open speech that covers 143 languages. Okay. Yeah, probably 11 Labs probably has done similar things to what Tortoise TTS has done, or some of those works. I think it's some combination of diffusion models and just peak transformers. That's it. Amount of hours. Okay. So here's the second component, the X to T, the into text translation and transcription. Here's the overview, unlabeled speech, 80-dimensional filter bank, codebooks, English to French. Hmm. The model is trained on X to English directions, and then in stage 2, these other ones are added. These are the worst diagrams I've seen in my life. I'm ranting so much. I'm gonna stop, or maybe I'm not gonna stop. Um, Statistics to train a model between SR, primary, and mind. Okay. Primary, you can see primary is always the smallest percentage. What language is this? Lit. This one is mostly primary. And then you can see how many mid-resource and high-resource languages we have. Obviously, Japan. Why do I have to turn my head around to see that to see this bar labels, man? Like, when using human labeled data, we remove special tokens such as uh, silence and no speech from the verbatim transcriptions. We additionally performed length filtering to remove examples exceeding a maximum text length. Of 100 subword tokens and pairs with a skewed text-to-audio length ratio that exceeds 5 subwords per second. Okay, so that's kind of some heuristics they're using to filter these datasets. Doing so improves the batching efficiency when training and limits pairs that are likely to be noisy or misaligned. Fair enough. Makes sense. What's torticoli? I didn't code anything so far. We're just skimming the paper at this point. But like along the way, we figured out it's like hopelessly. It's better to read the NLLB paper, which I did read before, and then just start playing with the codebase. Uh-huh. Stiff neck. Where's my to get it for? I'm not sure which context you're referring to, Rafael. Hopefully, I don't look like a turtle currently on the stream. Pseudo labeling, as with any sequence-to-sequence task, dependent on the availability of high-quality training data. Of course, pseudo labeling. Yeah, I have a feeling that this project is much more commercially important for them, and so that's why they're a bit less clear. But like, why write 100 pages of a paper then, man? Parallel data mining. this is just related work. That's why we're kind of skimming through the paper. But like ultimately, we're going to focus on the NLLB. I just wanted to see whether there are some insights to be had here before we go on to replicate the NLLB. Parallel data mining. Okay, so there is a big asymmetry between speech datasets and textual datasets. 128 million sentences for English, Italian, parallel corpus, whereas you only have 2 million pairs for audio. Okay, there's some filtering they do. Let's see this. By the way, did you see the demo of this project? Maybe we can try it. I'm not sure how it's gonna look like on the live stream. Seamless M4T demo. I'm not sure whether it's gonna work nice. Let's see. Let's say something. Why is your paper so confusing? Stop recording, and then let's pick a couple of languages, like maybe some of the languages I speak, like German, Portuguese, Spanish. I don't think they support Serbian here. Slovak, Spanish, Swahili, Swedish, Tagalog. Okay, translate. Let's see. I'm not sure where you're gonna hear that. Why do you think it's so confusing? Okay, they didn't even understand my English. My English is probably not that good at this point after 5 hours of streaming. Warum ist ein Fußball so verwirrend? That's completely okay. This is plain bad. Even if this was a sentence, which it was not, we get the why is your football game so confusing? Por que é que uma folha de papel é tão confusa? I have no idea what this means. Por que é tão confuso para atleta? Oh my God. This was a bad example because the system just messed it up. But when I used it the first time, I had some simple sentence like, and it was very good. I'm not sure which, maybe it's picking up a wrong microphone. I have some, let me see whether, it might be picking up a bad microphone, so it didn't hear me what I said. Anyhow, let's go back to the filtering part of the paper. Oh, this is just Adobe Reader. It's free. Okay, they do some toxicity filtering, a bunch of heuristics. I don't think this is going to be super useful to try and memorize. We remove spheres in which the text contains more than 20% emojis. More than, yeah, this is standard stuff to just assure some level of quality. Shows the base distribution of filter data. And then they mention again how they classify into high, medium, and low resource languages. Mid resource. Okay, the tokenizer using NLLB is trained using sentence piece using the BPE algorithm. Wait, isn't sentence piece a different tokenization algorithm compared to BPE? How can you say this sentence doesn't make sense? Many key Chinese words are missing from the original vocabulary. Basically both. The architecture is already implemented basically by them. So that part of the code, it's actually MIT, so that's not going to be the hard part. Collecting the data and doing all of that and training models, that's going to be the fun part. We can start with a smaller checkpoint. Like we'll start obviously with a 600 million, and then we'll go to higher and higher, like to 3.3 billion is the biggest dense checkpoint they released. And then we can maybe push it even above that. That's my idea, but like reduce the number of languages. We don't have to necessarily cover all of the 200 languages they cover. I would rather have a couple of dense points for similar languages from the same family group rather than taking their approach of mixture of experts. You're welcome, Abhishek. Okay, they do some hacks to include kanji from Japanese language and Chinese characters to improve the tokenizer, and then we trained a 256,000 sentence piece vocab on NLLB data for SeamlessM4T. The result improves the coverage, so it improves on Chinese by a substantial amount here. Okay, training a large-scale multilingual text-to-text translation model. They do the same thing. As you can see, like it's very much a derivative work of an NLLB project. And having a smaller language coverage allowed us to significantly decrease the size of the model, whereas the full model is, as I said, 54 billion parameters. We opted for one of the smaller architectures proposed in the NLLB team, the 1.3B dense model. Include over 75 million byte texts that were not included in the NLLB team. These concern Arabic, Mandarin Chinese, French, Russian, Spanish. Okay. I'm not sure if Umrit is still here, but like I completely agree with him that they should have like created one dense paper with like 10 pages and then a second one like this one. Like this almost feels like I'm reading an appendix section. We compare performance. Okay, they compare against the NLLB team and they get some better results for the translation here in both directions. Okay. They leverage foundational models either pre-trained on non-labeled data or trained on supervised high research tasks to improve the quality of transfer tasks. To use these pre-trained components. Okay, for the length adapter, we use a modified version of the M adapter, which I have no idea what it is, where we replaced the 3 independent pooling modules for Q, K, and V with a shared pooling module to improve efficiency. Okay, pointing to jointly optimize the following objective function. Okay, text and speech conditioned on. And there only text, and here speech and text. Just next token prediction for the source text and speech in the source language, and y is the target text in the target language. Optimize in. Thank you, Modern. Additionally, optimize an auxiliary objective function in the form token level to further transfer knowledge. Okay, just some languages to knowledge destination, knowledge distillation. From the strong MT model to the student speech translation task. The final loss is a weighted sum of all 3 losses. Okay, at least it's not 4 components like the previous module. Okay, let's kind of skim over these parts and see, speed it up a bit. So this describes the additional 2 building blocks. This is just a mess. There is no way I'm gonna cohesively. This is more of a complex system than like a model they're introducing. It's okay. Again, all of those components just broken down into some smaller pieces. The key to our proposed use of self-supervised discrete acoustic units. Speech to unit translation and a unit to speech conversion step. Okay. For speech to unit, model depicting figure 4 uses Unity as a 2-pass decoding framework which first generates text and subsequently predicts discrete. Guys, this is I won't remember 5% of the details here. I don't think most of this is relevant. Okay. I'm just skimming at this point. It was an ambitious goal to try and read every sentence of the paper, starting in the beginning. I kind of overestimated the amount. It's not the same when I'm reading solo versus on a stream, as I'm usually just not commenting and stuff. To overcome the data scarcity, it is common practice to use TTS models to convert text from speech to text datasets into synthetic speech. This synthetic speech is in turn converted into units using the previously described unit extraction pipeline. And this two-step unit extraction process is a slow process and is harder to scale given the dependencies on TTS models. High-quality, off-the-shelf TTS models are hard to come by for all languages, especially for low-resource ones. Training reliable monolingual or multilingual TTS is not as scalable given the challenges around gathering the high-quality data. To overcome this, we circumvent the need for synthesizing speech, blah, blah, blah. And train multilingual text-to-unit models on all the 36 target speech languages. Got it. Okay, so they just kind of don't go the whole way to the speech. They just create this data set where they convert text into speech units, which are then converted into speech using vocoders later on, I guess. To remove outlier samples from our pair data, we filter based on the number of seconds, discarding any pair with a ratio exceeding 0.5. Figure 8 shows the distribution of all the data used to train the model between the primary and the mine data. Didn't we see a similar chart before? Statistics of, we show the data size in hours of speech between primary and mine in ascending resource level. Obviously Spanish is up top in there. Deutsch, German, hours of, okay. Okay, so this is now a text to unit. Performing the pseudo labeling from the previous section, the thing they just mentioned, and then initializing the T2U component in the unit type, which is this bigger module, I suppose, from before. I don't like that they are not mentioning compute anywhere. When you want to replicate this, obviously you want to know how many GPUs, how many compute hours roughly do you need. Again, so I'm just distilling the knowledge from the bigger T2U model. Okay, stage 3, fine tuning. Initialize the multitask. Okay. So again, just a bunch of steps. Now that they've trained these smaller unit models, then they embed them in the larger system and then do fine tuning of the whole thing. 2.3 billion parameters for the biggest model of theirs. Fine-tuned in 95 languages, 96 for ASR. They trained the smaller, the medium model. We pre-trained a smaller BERT with 300 million parameters and used a distilled model from NLLB team. Okay. Number of parameters, here is it broken down across the components. In total 2.3 billion, and the smaller one, the medium one, is what, 1.2 billion, roughly. Evolves, okay. Is anybody still following at this point? During the I definitely have to improve the lag next time. It doesn't feel good if you're behind me 40 seconds. Aryan asked some question. Can you please explain the statement for some source languages? Our models are evaluated zero shot to reach the coverage described. I'm not sure where that sentence is. And let's first maybe wrap it up and then I'll try and find it if you're still around. Comparison to cascaded approaches. Okay, we've seen this in the beginning. Kako ide, asks Lion in Serbian. Ide odlično. We also add, okay, table 15. I guess we can just see this wall of text summarized in these tables here. They mention table 15 and table 14. Ariane, just let me know the actual page and page number, and then we can go back later and see whether we can interpret it together. Okay. They compare against MMS and Whisper. They outperform MMS variants evaluated with CTC by more than 6% word error rate. Okay. The additional try and compare against those baselines for a certain bucket, like low resource languages. Let's see those numbers. Let's see what's going on here. So Whisper, Audio Palm, SeamlessM4T, type direct, cascaded, sizes. You can see the sizes here. This one is 8-bit, that's fairly big. And this, the seamless model achieves the best blue score when converting into English. When converting from English to a different language, then they are behind behind Whisper. Wait. To text. Okay, so that means, at least on this dataset floors, they are roughly on par with Whisper when it comes to translation from a speech to a certain language. Wait, but like Whisper can only translate into English unless this is ASR. Yeah, I guess this is just ASR. Okay, let's skim this. Speech to text on these different data sets. Let's see how it compares against Whisper. The reason I'm comparing against Whisper, even though Audio Palm is apparently better, is because it's open source. You can actually run it on your own machine. It seems it's much better than Whisper, although it's also much bigger. A better comparison would be the medium model against Whisper Large V2. And here ASR. Okay, nice. It would be good to test this in practice against Whisper. Zero-shot text-to-speech translation. Off to a mini break. I'll be back in 2 minutes. Let me just go grab some water. See you soon, guys. Okay, I'm back. Second. Where are we at? I'm back. Okay. Zero-shot text-to-speech translation. So in table 20, they report those scores. Let's just compare. Non-English speech source. Most challenging input to translate with our model. Okay. Yeah, I think we're not going to extract anything super insightful from here. Average SP Blue across languages, obviously English, and then all the other languages are worse off. Oblations, let's see whether there is something interesting here. By the way, let's just quickly, let's try and, this is page 41, let's see where did they mention GPUs, like just to see. Okay, so here's the first mention, 32 GPUs there. Okay, we saw this one. This was for training the LID system, the language identification that's used for the mining process. Then they mentioned GPUs here, but they didn't really say how many GPUs they needed for mining. And that's it. That's not really super descriptive compared to like NLLB. They used to mention many more details. Hours, let's see whether they're going to mention compute hours somewhere. Compute hours, nope. Total, trying to find the total amount of hours that was spent on compute. And yeah, this reader is completely broken. This used to show, I don't even know how many matches there is. It's like, I really don't ask for too much. They just mentioned the amount of hours in the data set, but not the actual compute hours. If anybody finds, okay, they did mention for training. Again, this is, yeah, I don't think they mentioned it anywhere. Okay, definitely not informative. Let's skim through the experimental setup here. Conformer layers, 600 million parameters. Our learning rate increased up to 4,000 warm-up updates. We trained on 32 GPUs with a batch size of 960,000 frames in each for 100,000 updates. I guess we can infer stuff from here if they mentioned the type of GPUs they're using. I assume they're using a 180 gigabyte. I think that's how Meta's cluster looks like. They summarize the ablations here. Okay. Quantization with 2 GVQ code books outperforms normal quantization with a single one. Ablation dataset. We trained all models for 100,000 updates. Without adding this loss. Fine-tuning exclusively on speech-to-text leads to catastrophic forgetting of the pre-training T2T. Okay. Multitask learning is necessary in order to prevent catastrophic forgetting. Surprise, surprise. Okay. This is literally the appendix section of normal papers. The results in table 25 show that adding mine data improves English to foreign language translation accuracy by 0.5 blue points, but it decreases that of English foreign to English by 0.2. Related work, we can skip that. Automatic and human eval. I think we're almost done with the paper, guys. Like, it's not really insightful. I didn't expect it to be this verbose and yet like, I don't know, too many details and not coherent, like diagrams. Okay, they mention now again this Blazor 2.0, which they use for evaluation. I don't think that's that important. Understanding exactly how Blazor 2 works. You can just treat it as a black box. Three-layer perceptron with 10H. I haven't seen NLPs mentioned like this in a while. Why not just a transformer? Okay, Pearson correlations with unsupervised and supervised Blazor models with XSTS scores, basically showing how nicely does it correlate with these human scores, thus showing us how good this is as a proxy for human judgment. Finally, the human evaluation. I'm curious to hear a bit more about how they've done the eval here and see the results. Just skimming at this point. Let's first see the results. If there is any such table, let's just see. Two tables there. Limitations. Robustness. And then there is the responsible AI that we said we are not going to go through. We're not responsible. Just a second, let me just scroll here. Okay, let's figure out what they've done here. Median score again here, blah, blah. They were calibrated, the usual stuff. Okay, has up to 3 recorded audio spoken by different speakers. The quality review requirement means that each language may not have a recording for all the 350 sentences. we'll list the languages and modalities related with each protocol in table 28. Okay, let's just skim through the tables. Guys, why do they I just need to see the scores. I don't want to see how many languages you covered for your baselines. This is crazy. Preliminary human evaluation results. Yeah, let's just skim through the tables. We can ignore the text safely. Okay, so here it is. They compare against Whisper because I assume the audio poll didn't have the results reported or something for human eval. Obviously a bit better than Whisper. In what is this translation? And then close to human reference from English into foreign language. Average HSTS human evaluation results into and out of English over all 22 evaluated languages. Results were computed for each language direction. Okay. Speech to text modality. Here is the average XSTS into two different direction classes. Whisper. Okay. So less variance. Robustness against background noise. Okay, I'm not going to go through these details here. Yeah. Well, we tried. Overall, the paper was too long. Didn't give any anything that's actually. I wanted to see like numbers like how many GPUs did you use? How many compute hours did you need to train each of these components of your system? They have these 4 broad components. Let me just find the diagram. Yet none of that information was in there. Also, the diagrams explaining how those components work were mostly not that informative. They just delegated that to previous work. This one was nice though. But even this over segmentation part, like there's this diagram with over segmentation, was not completely clear until we went and opened the different paper. That's a sonar for mining. All in all, there is just a ton of details and there is no single cohesive story, which is understandable because this is not like your transformer paper. This is more of here's a system we made. So my audio is broken again. Okay. Do you hear me now? It should be good. But either way, we are wrapping it up. Sorry about this. It's gonna be better next time. Learning in public, that's how you do it. I just streamed 4 hours of going through this thing. Okay, guys, so let me know if you can hear me. Is it better? Basically, next up, I'm gonna open up the codebase and skim through the codebase, and I'm gonna stream that a bit later today as well. And then tomorrow, I will basically focus on starting the replication effort for NLLB. So I'm gonna start with data. Thanks, guys. I'm gonna start with data, and I'm gonna start a channel basically on Discord to get people who are excited about this to interact from the get-go, and then we'll take it from there. Again, this is super experimental. I've never done something like this. I wasn't sure whether people want to actually stick around. Maybe you can just use it as to like a study with me type of a thing, or you can just follow along as well. I know it was slow. You can, if you went by yourself, you could probably go much faster to go through a paper. But hopefully you found some value in this stream. I know it's fun for me because I'm just experimenting here. Awesome, guys. I'm logging off for not for today, but like for now, and then catch you later. I think I have some meetings now at 6 p.m. Well, we actually have guerrilla authors coming to our Discord, so that's gonna be fun. And after that call, I'm gonna start screaming. I'm gonna start streaming again, and we're gonna go through the code base of Fair.sec 2, and we're gonna go through the SeamlessM4T code base as well. Peace out. Until then.